Moving on to the first question. ABCD is a quadrilateral in which P, Q, R and S are midpoints of sides AB, BC, CD and DA respectively, and AC is diagonal. Show that SR is parallel to AC and SR is equal to half times AC. Second, PQ is equal to SR. Third, PQRS is a parallelogram. Now moving on to the solution. He has given that ABCD is a quadrilateral in which PQR and S are midpoints of sides AB, BC, CD and DA respectively, and he also given that AC is diagonal. He asked us to prove that. First thing, SR parallel to AC and SR is equal to half AC. Second, PQ is equal to SR. And third, PQRS is a parallelogram. Now, in order to prove those, let us follow a procedure. Initially, let us consider triangle DAC. In triangle DAC, S is midpoint of DA and R is midpoint of DC. Then from midpoint theorem we can say that SR is parallel to AC and also SR will be equal to half times AC. This is what our first proof required. Now if we consider in triangle ABC, P is midpoint of AB and Q is midpoint of BC. Then from midpoint theorem we can say that PQ is equal to half times AC. Let it be as second equation. From proof 1 and equation 2 we can say as SR is equal to half AC and PQ is equal to half AC, SR is equal to PQ. This is what our second proof required. Here we can also say that from midpoint theorem PQ is also parallel to AC. Now in the first proof we got that SR is parallel to AC, and in the second proof we got that PQ is parallel to AC and PQ is equal to half AC and SR is equal to half AC. So here we can say that PQ is also parallel to SR. Now here SR is equal to PQ and PQ is parallel to SR. Here we can say that in quadrilateral PQSR, opposite sides are parallel and are equal. If in a quadrilateral opposite sides are parallel or equal, then we can say that the quadrilateral is a parallelogram. Therefore, PQRS is a parallelogram. Moving on to the second question. ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rectangle. Now moving on to solution. Given that ABCD is a rhombus in which PQRS are midpoints of sides AB, BC, CD and DA respectively. Let us draw a figure regarding it. We need to prove that PQRS is a rectangle. In order to prove this, let us follow a procedure. In the first step, let us join BD and AC. Now, let us consider the triangles, triangle PAS and triangle QCR. In these both triangles, angle A is equal to angle C since opposite angles in a rhombus are equal, and also AS will be equal to QC. Since we know that in rhombus all the sides will be equal, S divides AD in its midpoint and Q also divides BC in its midpoint, so AS is equal to QC, and similarly AP is equal to RC. Now here in both the triangles, two corresponding sides and an included angle in between them is equal. So by SAS property we can say that triangle PAS is congruent to triangle QCR. When two triangles are congruent, we can say the corresponding sides and corresponding angles can be equated. So here let us equate PS is equal to QR. Similarly, let us consider the triangle PBQ and triangle SDR. In these two triangles, angle B is equal to angle D. Since ABCD is a rhombus, opposite angles in a rhombus will be equal. Here SD is equal to BP. Since S is midpoint of AD and P is midpoint of AB, we know that AD is equal to AB, and similarly we get DR is equal to BQ. Now again by SAS property, the two triangles are similar. So triangle PBQ is similar to, here by SAS property the two triangles are congruent, that is triangle PBQ is congruent to triangle SDR. As two triangles are congruent, then their corresponding sides and corresponding angles can be equated. So here SR can be equated to PQ. In the first step we got that PS is equal to QR, and here we got that SR is equal to PQ. Two pairs of opposite sides are equal. So here we can say that PQRS is a parallelogram. As PS is parallel to RQ in triangle ADB. Now if we consider in triangle ADB, S is midpoint of AD and P is midpoint of AB. Thereby midpoint theorem we can say that PS is parallel to BD. Let us assume that the points where AC and BD intersecting, PS RQ, SR and PQ as E, F, G and H. Now we consider that PS is parallel to RQ and we got PS is parallel to BD. If we observe clearly, HSGO also forms a parallelogram. As PS is parallel to BD, we can say yes, H is equal to GO and SH is also equal to GO and HS is also parallel to GO. So we can say HSGO forms a parallelogram. As HGO forms a parallelogram, we can say in parallelogram opposite angles are equal. Therefore, angle HOG is equal to angle HSG, which is equal to 90 degrees. As angle HOG will be equal to 90 degrees since in rhombus diagonals bisect perpendicularly. So we can say here we got angle S is equal to 90 degrees. Now we know that PQRS is a parallelogram and in which one of the angle is 90 degrees. Then we can say that PQRS is a rectangle. Moving on to third question. Given that ABCD is a rectangle and PQR and S are midpoints of sides AB, BC, CD and DA respectively, show that quadrilateral PQRS is a rhombus. Now moving on to the solution. Given that ABCD is a rectangle and PQR and S are midpoints of AB, BC, CD and DA respectively, and he has asked us to prove that PQRS is a rhombus. Now let us move on to the procedure. Now in the procedure, in the first step, let us consider two triangles, that is triangle DAC and triangle BAC. Now here in triangle DAC, S is midpoint of AD and R is midpoint of DC. So here by midpoint theorem we can say that SR is parallel to AC and SR is equal to half times AC. Now in triangle BAC, P is midpoint of AB and Q is midpoint of BC. So here by midpoint theorem we can say that PQ is parallel to AC and PQ will be half times AC. In the initially when we consider triangle DAC, we got that SR is equal to half AC and here we got PQ is equal to half AC. So we can say SR is equal to PQ. Now in quadrilateral PQRS, two opposite sides are equal and here we get another condition, that is SR is also parallel to PQ. Here now in the quadrilateral PQRS, we got the condition that opposite sides are parallel and are equal. So we can say PQRS is now a parallelogram. Here, in order to prove that PQRS is a rhombus, let us consider the two triangles, that is triangle PAS and triangle PQB. In these two triangles, angle SAP is equal to angle QBP is equal to 90 degrees, as ABCD is a rectangle, and AP is equal to PB since P is midpoint of AB. Now, as ABCD is a rectangle, AD is equal to BC, and as S is midpoint of AD and Q is midpoint of BC, we can say here AS is equal to BQ. Now here in triangle PAS and triangle PBQ, according to SAS property, the two triangles are congruent. That is, triangle PAS is congruent to triangle PQB. When two triangles are congruent, we can say that the corresponding sides and corresponding angles will be equal. Therefore here PS will be equal to PQ. Now in parallelogram PQRS, we have got that adjacent sides are equal. Here we know that a parallelogram with adjacent sides equal is a rhombus. Therefore we can say PQRS is a rhombus.